Need to see what devices are lurking on your network? In this video, we will be looking at using ARP-related utilities to map out a network. Please help me out by hitting the subscribe button so I don't break a sweat. In this video, we're going to be looking at the arp command and other commands which uses the arp packets to detect hosts on the network. The tools we are using in this video, arp, arp-scan, arp-fingerprint, and netdiscover, are all already preloaded on CAINE, Parrot OS, and other incident response Linux distros. So you can follow along using any of those distros, or see the description below if you need to download them. When computers on a network communicate with each other, they will use the MAC address, which is the physical address of the network interface. The Address Resolution Protocol, otherwise known as ARP, will resolve a 32-bit IP4 address to a 48-bit MAC address. Once you have resolved an IP, your computer keeps track of the IP to MAC address mapping in a table called the Address Resolution Protocol, or ARP table. You can view this table by just typing the command ARP. We see that we already have 4 entries populated in our ARP table. Right now we have a computer named Fedora, which is mapped to this MAC address. We have a machine named CAINE, which is mapped to this MAC address. We have a machine named Kali that's mapped to this particular address. We have a machine at this particular IP, which does not have a host name resolved. That's why it's listed as an IP address, and it's mapped to this MAC address. arp-a shows similar information, but in a slightly different format. It's a little more condensed. One of the other things we want to know is, instead of actually looking at the host names, we might want to actually just see the IP addresses. And so in order to see the addresses instead of the host names, we can just do arp-n for no resolve, or numeric. You can use -n or --numeric. It'll give you the IPs instead of the host names. Let's look at how the arp command affects the network by looking at the traffic on the network. We can run the tcpdump command on another terminal. I'm going to filter out for anything where our machine is a source of arp traffic, and also when our machine is the destination. So I'm going to type sudo tcpdump -i enp0s3. That's the interface we want to monitor. And then I want to filter for anything where our machine is the source of arp traffic. So I'm going to put source host 10.0.2.12, which is our IP, and arp, or whenever our machine is the destination. So dst host 10.0.2.12. So let's go ahead and start with a clean arp table. Let's type arp to make sure it is clean. So there's nothing here. And I'm going to go ahead and initiate an outbound ping to another machine. So I'm going to do ping 10.0.2.11-C3. Right, so once that's done, it comes back. Let's look at our arp table again by typing arp. The machine 10.0.2.11 is now in the arp table because when we did a ping command, our system first had to find out the MAC address for that machine, 10.0.2.11. So our machine sent out an ARP request to the local network. And the machine .11 was on the network, so it responded to us with its MAC address, which gets filled into our ARP table. And then the ping command proceeds. Let's take a look at the tcpdump activity to match what we think happened. And as we can see here, our machine sent out a ARP request for the machine at .11. And then we received an ARP response with their MAC address. And then we see the 3 successive ping replies. So it did what we expected it to do. Next, I'm going to initiate an inbound ping from another machine, 10.0.2.17. So on this other machine, I'm going to do ping 10.0.2.12, which is our local machine, -C3. From here, it looks like everything succeeded. Let's go back to our original machine and do an arp command again to look at the arp table. Now we see the machine with the IP 17 in the table because when machine 17 wanted to ping us, they had to send out an ARP request to find out our MAC. Looking at the tcpdump activity, we can see that our machine received a ping request from the machine 17, to which we responded with a ping reply. And this happened 3 times. Then we see 17 send out a ARP request for our machine CAINE, and then we respond with our MAC address. And then we send out an ARP request for 17, and they come back with an ARP reply containing their MAC address, therefore adding an entry into our ARP table. And we see this reflected when we looked at our ARP table. Let's take this one step further. Let's go ahead and try to ping a machine that has a firewall that blocks pings. Would this stop our ARP table entry from getting updated? Let's go ahead and ping 10.0.2.10-C3. Right, so on this particular machine, I had set up a firewall that blocks pings. And as you can see, nothing went through. Right? There's no response back. But let's take a look at our ARP table. We do see the machine .10 in the ARP table, even though the ping was blocked by the firewall. The ARP still gets resolved, which is interesting. Let's look at the tcpdump activity. We can see that our machine sent out a ARP request for .10, and then we received a reply with their MAC address, and then that was it. There is no ping responses. So again, this matches with what we had thought. Last thing we're going to do here is to ping a machine that doesn't even exist. So I'm going to go ahead and ping 10.0.2.13-C3. So as this machine goes out and tries to ping this non-existent machine, it's going to fail and come back. Let's take a look at our ARP table. Now we see the entry for machine 13 in the table, but it has the word incomplete under the hardware address because that machine does not exist. Right? When our machine tried to do an ARP request, nobody responded with an ARP response. So our machine wanted to note that and put it in the ARP table. So let's take a look at the tcpdump activity. We can see that our machine sent out a ARP request for machine 13. And seeing no response, it sent out 2 more ARP requests with no responses. And so that makes sense that there is no machine with that IP, and so no one is going to respond. So once again, this matches up with what we expect. Another command that uses ARP protocols is arp-scan. This command actually will help us go out to the network and scan it, giving us possibly valuable information. First, I'm going to run tcpdump in another terminal so that it can tell us what's going on in our network. I'm going to filter for anything involving our machine, which is 10.0.2.12, so that we can see what traffic arp-scan generates. So I'm going to do sudo tcpdump -i for interface, and then specify enp0s3 or Ethernet interface. And I'm going to filter for anything involving our machine at 10.0.2.12. So I'm going to type host 10.0.2.12. arp-scan is useful in that even firewalls and other hosts with IP filtering that drops all IP traffic will respond to ARP requests. So this makes it a very useful tool to quickly determine all of the active IP hosts on a given Ethernet network segment. So the simplest way to run it is basically using sudo arp-scan-l. -l will scan the local network. So when this comes back, we can see here, it tells us the interface that it used, gives us our MAC address for that interface and our IPv4 address. And then it tells us essentially, because we are on this network, we have 256 possible hosts. It is able to enumerate 4 machines on here. So it gives us the IP, and then the MAC address, and then based on the MAC address, it actually makes a guess as to what type of machine it is. So in this case, I have an Arlo camera, some kind of Intel NIC, a Hikvision camera, and then a WiseCam. With arp-scan, by default, it will scan all available interfaces and the entire network. But we can control the scanning by giving the specific interface and limit the network by using CIDR masking. So in this particular example, I'm going to type sudo arp-scan --interface equals enp0s3, and then I'm going to give it the subnet of 10.0.2.0, and then the CIDR masking of /27. So the masking of /27 will basically only scan the 32 addresses starting from 2.0 up to 2.31. And as you see, it comes back with the same 4 hosts that was discovered with the previous command, but it just did it a lot faster if you look at the time difference here. So what is it that arp-scan is doing on the network exactly? Let's take a look at the activity from tcpdump. We can see here that the machine CAINE, which is us, sends out an ARP request for each of the IPs in the range. And we see that certain machines respond with their MAC addresses. So .4, .10, .11, .17, they all respond. And then we can see that the ARP program basically does this twice. And the second time, it's only to the machines that did not respond the first time. And you can actually change this behavior with the -- retry option if you want more or less number of retries. One thing to note is that arp-scan does not update the ARP table. So if you're looking for something that updates the ARP table, this is not it. And arp-scan is also quite noisy. As we saw, it goes and does a ARP request to every single machine on the subnet that you specified. So depending on what you are doing, you may or may not want to be that alerting on the network. If you want to take one extra step in network scanning and want to see the operating system of the target machine, we can use the arp-fingerprint command. First, we're going to set up tcpdump to run in another window so we can see what the arp-fingerprint command is doing. So I'm going to type sudo tcpdump-i enp0s3, and then I'm going to filter for anything that involves our machine, so host 10.0.2.12. To run arp-fingerprint, we just need to give it a host name or IP address. So sudo arp-fingerprint. So in this case, I'm going to do 10.0.2.4. And when it comes back, what we see is one line of output where the first column is the IP that you specified, then a fingerprint consisting of ones and zeros, and then the third column is a guess from the program as to the operating system that the target host is running. So in my case, it says that it's a Linux kernel 2.4, 2.6, which is a little dated. This one has a more up-to-date kernel that I'm running. Looking at the tcpdump activity, we can see that the arp-fingerprint is pushing out data that's a little more than just the ARP requests. So you can see blocks of data here. So this is the data that is pushing out to the target to see how it responds. So then that's how it does its fingerprinting. With arp-fingerprint, you cannot specify multiple targets on the command line. So to fingerprint all the hosts on the local network, you can use the -L option. Or if you have specific hosts you want to target, you can use a script that calls arp-fingerprint with each one of those targets of interest. So here I'm going to do sudo arp-fingerprint-l for local network. And here we see the different machines that I have on my network, and then the guesses of the operating system. So once again, my .4 machine is a Linux machine, but not running any of those kernels. My .10 machine is a Windows 10 machine, and the other two are Linux machines running kernels that are a little bit more recent than the ones that are listed. So maybe our fingerprint is not the most accurate. And let's take a look at the tcpdump activity. So here we can see that the machine, our machine, sends out a lot of ARP requests for each one of the IPs in the range in the local network. And then we can see that certain machines responded with their MAC addresses like .4, .10, .11, .17. And once again, we see the arp-fingerprint program then send out the various different ARP packets to those targets to solicit different kinds of output so that they can be fingerprinted. Another tool that uses ARP reconnaissance is netdiscover. This tool can passively detect online hosts or actively search for them by sending ARP requests. You can even use this tool without having to join the network with a valid IP address. To show this, I'm going to take down the network interface, and then I'm going to delete my current IP that's on the 10.0.2 network. And then I'm going to give myself an IP in the 192.168 network, and then turn the interface back on. So I'm going to do IP address to see what my current settings are. Then I'm going to take the interface down by doing sudo IP link set enp0s3 down. I'm going to go ahead and delete my current IP address. So sudo IP adder del 10.0.2.12/24 dev enp0s3. And then I'm going to add a address in the 192.168 network. Sudo IP adder add 192.168.33.55/32 dev enp0s3. Then I'm going to go ahead and bring that interface back up. Sudo IP link set enp0s3 up. And I'm going to verify my IP with the IP adder command, and we can see that we now have the 192.168 address. All right, so first we're going to set up tcpdump to run in another window so we can see what netdiscover is doing. I'm going to type sudo tcpdump -i enp0s3, and I'm going to filter for anything that comes out of this machine. So source, host, 192.168.33.55. And I'm filtering for anything that comes out of this machine is because I want to see what netdiscover is doing to the network. All right, so to run netdiscover, we can specify a network interface to look at. So I'm going to do sudo netdiscover -i enp0s3. That's the network we're going to look at. The first method I'm going to try is using the option -p for passive, because it's much quieter on the network and it doesn't send out ARP requests. So all it does is just sits and listens. The default mode for netdiscover is an interactive menu. And so it takes over your screen and it tells you what it's doing up on top. You know, if it's actually scanning, if it's actually looking at specific networks and so forth. And then it will tell you how many ARP requests and reply packets it's seen and the number of hosts it saw. And then once it starts populating the table underneath for each IP that it finds, it's going to tell you the MAC address, the number of times that it saw the ARP request packets or ARP reply packets, and so forth. And if you have a ton of hosts that are listed here, you can use the J and K keys to go up and down. And then when you are finished with running this command, you can type the letter Q to quit to get back to your command prompt. So in this particular run, we see that it spotted the machine .4 and .10. And so those are the two machines that are active on the network doing something. I don't know what they're doing, but they're doing something. And so they are basically sending out and or receiving ARP requests and responses. That's why they get picked up by this program. So if we look at tcpdump output, we see that there really is not any activity from our machine. So running it in the passive mode does not make any noise on the network. All right, now let's go ahead and run it in a different mode. Let's not use the passive mode. Let's actually just let netdiscover do its thing, however it does it. And this time we're going to use the -r option to limit the range of where it's going to search for the subnets. So I'm going to do sudo netdiscover -i enp0s3 -r 10.0.2.0/24. So this time it picked up a lot more machines on this network. It picked up the .4, .10, .11, and .17. And notice in this field called count, for the .4 machine, it's had 65 ARP requests seen. So this machine is definitely actively doing something on the network. And similarly with the .10 machine, it has a count of 13, so it's also doing something on the network. For .11 and .17, the count is 1. So basically those are ARP requests that were initiated by the netdiscover program. And we can verify this by looking at the tcpdump output. Once again, when you're done, type the letter Q to quit, get your prompt back. netdiscover will also allow you to read in a list of ranges to probe. And so you can edit a file and add the subnets into that file. Then one thing to do is make sure you only put one network per line and no blank lines. So we're going to go ahead and do a VI of a file called range.txt. And what we're going to do is we're going to go ahead and add the network here, 10.0.2.0/24, 192.168.0.0/16. And now to run netdiscover, to read that file, we just got to do sudo netdiscover-i enp0s3-l, and then the file name called range.txt. And again, we see the same 4 devices that we saw earlier, which is obviously fine because now we're just specifying the same ranges to go over plus additional ones. And when you're finished, you can type letter Q to quit. So one last thing about netdiscover is, because we're running in interactive mode, if you actually redirect the output to a file, it's going to look really horrible. So in order to actually generate a file, you can use the -P, and then you can redirect the output. So you can do sudo netdiscover-i enp0s3-P, and then redirect into a file. I'm going to call it netdiscover.t. And then when it's done running, you can hit Control-C to terminate the process. And then after that, we can look at the file. We can do more of netdiscover.txt. And you can see that it saw the 2 machines on our network. So by using the ARP protocol, we can use tools like arp-scan, arp-fingerprint, and netdiscover to help map out a network. The benefit of ARP protocol is that you don't need to be part of a network by having an IP assigned. You can also see hidden devices which are not responding to pings or other requests. And this is an important building block for understanding ARP spoofing and man-in-the-middle attacks. For more videos on the CAINE Forensics distro, make sure you watch these videos here. Or if you're interested in learning more about networking, watch these videos here. Make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.